This is Advanced Math, Unit 5, Lesson 7. Solving trig equations continued. All right, solve for x such that x is greater than or equal to 0 degrees and less than 360 degrees. A notation you're going to see in your textbook, if you haven't seen it already, is a notation that you learned last year. Interval notation you learned in Math 3. Looks like this: 0, 360. Bracket on 0 because 0 is included, parentheses on 360 because the 360 is not included. So when you see this, know it means the same thing. All right, number 1. 2 sine x plus cosecant x equals 0. All right, so you see this on the test and you're thinking, okay, what can I do? What should I do? You can't factor anything, but hoping you recognize that you can change this. So it's 2 sine x plus 1 over sine x equals 0. And we've cleared fractional equations before. We spend a whole first unit on this, or second unit on this kind of stuff. We clear by multiplying everything on both sides of the equation by sine x sine x times 2 sine x is 2 sine squared x, plus that reduces to 1, equals 0 times sine is 0. You are going to subtract the 1 and divide by 2. Sine squared x equals negative 1/2. Again, that's subtracting the 1, dividing the 2. And then you square root both sides. And we've talked about this before. You cannot take the square root of a negative, so there's no real solution. All right, number 2. 2 sine squared x plus 3 sine x plus 1. Now this one is a definite on the test. And I pointed out because kids tend to struggle, they forget how to do something like this. And I forgot to give you the rest of the equation. Of course, it equals 0. It's not an equation without an equal sign. Okay, the biggest hint suggestion I can give you is substitution. Let u equal sine of x. And when you do that, you can see it's going to look a lot easier on the eyes. 2, if I change sine to u and it's squared, it's 2u squared plus 3u plus 1 equals 0. Can you see how if you see this, most of you can look at that and like, oh, I know how to factor that. Where when it's written like this, it's not as easy to see on the eyes. Some of you can factor right as it is. You don't have to use u substitution, and that's perfectly fine. You want to be there eventually. Everyone wants to be there eventually. Okay, 2u times u, because 2u times u is 2u squared. I know it's going to be 1 times 1 because 1 times 1 is 1. They have to be the same sign because this is positive, and that tells me that they are both plus. 1u and 2u gives me the 3u in the middle. So we are happy, we are good. I solve each one. 2u plus 1 equals 0. U plus 1 equals 0. This means u equals negative 1/2. U equals negative 1. And I can now plug the u back in so I can solve. Sine of x equals negative 1/2, and sine of x equals negative 1. Do you see how nice that worked out? We plugged in u, factored our trinomial guess and check. We checked it, 1u and 2u gave us the 3u. We solved each one by using the zero product property, setting each one equal to 0 and solving. We plugged sine back in to the u. Sine of x equals negative 1/2. Sine of x equals negative 1. And now we're going to solve. Sine of is 1/2. Hopefully you're thinking 30 degrees. Sine of 30 degrees is 1/2. Is 30 degrees going to be one of our answers? No, because it's not in the first quadrant, because it's negative. What two quadrants is sine negative in? The bottom two. So what is 30 degrees in the third and fourth quadrant? 210 degrees and 330 degrees. Sine of x equals negative 1. That's a quadrantal. It happens there at the 270. And that there is your set of answers. So you can see, not too bad once you recognize what type of problem it is. I have sine squared, I have sine, I have a constant, trinomial guess and check. Factor as it is if you'd like. If not, then use substitution. Okay, number 3. 2 sine squared x equals 2 plus cosine of x. Excuse me. All right, so I'm going to get everything to one side to get equal to 0 to see if there's anything I can do. So I'm going to move this over, give me 2 sine squared x minus cosine x minus 2 equals 0. Now, there's no GCF. I can't change everything to sine and cosine because everything is already sine and cosine. And it kind of looks like this one, but I can't factor it because this is sine squared and this is cosine. So I'm kind of stuck here, but if you recognize that this is squared, meaning I can use a Pythagorean identity. 2 parentheses minus cosine x minus 2 equals 0. Everything's staying the same, except I'm going to change the 1 minus sine, I'm going to change sine squared x to 1 minus cosine squared x, because that is one of our identities. Sine squared becomes 1 minus cosine squared. Distribute the 2. Minus cosine x minus 2. I'm going to pause here and come up here and tell you this is another one on the test that kids tend to struggle with. They get stuck up here, they're not sure what to do next, or they do this and then they just combine things incorrectly. These two are not like terms. Cosine squared and cosine, they're not like terms, but the 2 and the negative 2 are, and when you add them together, they undo each other, leaving me with negative 2 cosine squared x minus cosine x equals 0. So what you have to ask yourself is this a factoring like number 2, where I'm going to do a trinomial guess and check? No, there's only 2 terms. What kind of factoring is it? It is a GCF. Taking a look, what can I take out? I can take out a negative 2 cosine x. If you don't want to make it negative, leave the negative in there, and the 2 is not coming with it, sorry. Negative cosine x. If you don't want to take out the negative, leave the negative in. Okay, so that leaves me with positive 2 cosine, because if I multiply these two in, I get negative 2 cosine squared x plus 1 equals 0. Negative cosine times 1 is negative cosine. And now again I'm going to use excuse me, I'm going to use a zero product property. Negative cosine x equals 0. 2 cosine x plus 1 equals 0. Divide both sides by the negative 1. Cosine x equals 0. Subtract, divide. Cosine x equals negative 1/2. All right, divided both sides by a negative. 0 divided by a negative 1 is still 0. Subtract the 1, divide the 2. That gives me negative 1/2. Cosine of x equals 0. There's two places where cosine is 0. That's at 90 and 270. Cosine x equals negative 1/2. Your reference angle is 60 degrees. What two quadrants is cosine negative? Quadrant 2 and quadrant 3. So you ask yourself, what is 60 degrees in those two quadrants? 120 and 240. And those are your answers. 90, 270 from this one, and 120, 240 from this one. Okay. Number 4. The next few are going to be new problems. New, we haven't seen these typed before. Let me show you what I'm talking about. Sine of 2x equals negative 1/2. Okay, so what this is, we haven't seen this 2x here before. First off, this is not the same as this. Let me write it out. I'm going to erase it. If it was something like this, I could divide both sides by 2 and move the 2 over. When it's like this, I cannot divide both sides by 2. So recognizing that those are two different things, I am not allowed to, cannot's mathematically incorrect if I try to divide both sides by 2. So I'm going to use substitution. Theta equals 2x. Sine of theta equals negative 1/2. That I can do. Sine of what angle is negative 1/2? Your reference angle is 30, because sine of 30 is 1/2. It's not 30 degrees because it's not in quadrant 1. Which two quadrants is sine negative? Bottom 2. So you find your 30 degrees in those bottom 2 quadrants. So it's going to be 210 and 330. Okay, so far nothing new. Here is where the new part takes place. 2x means you're going around your circle twice. You've done it once already, giving you the 210 and 330. It gave you the 30 degrees in quadrant 3 and the 30 degrees in quadrant 4. What you're going to do is go around again, because it's a total of 2 times. 2 times because it's 2x. So what you're going to do is find your coterminal angles for 210 and 330. And how do you do that? By adding 360 to each one. So here's our first set. We are finding our second set by adding 360 to 210 and 360 to 330. Go ahead and do that now. Add 360 to each one. That gives you 570 degrees and 690 degrees. Okay, but this is not, this is what theta equals, but theta was 2x. So what we do is we go and we divide everything by 2. Now, before I divide by 2, I'm hoping you recognize that these answers don't look right, because earlier we said our answers have to be between 0 and 360. And these two are not within that restriction. So it's going to clean that up though when we divide everything by 2. So go ahead and divide all these numbers by 2. and see what you end up with. X equals 105 degrees, 165 degrees, 570 divided by 2 is 285, and 690 divided by 2 is 345. And sure enough, all of our numbers are within that restriction, 0 to 360. What would happen if I did, I'm going to put a little squiggly line here. What if I did continue one more time just because I wanted to? So I added 360 to 570 and added 360 to 690. I would get 930 and 1050. That's by adding 360 to these two and then adding 360 to those two and dividing everything by 2. My numbers come out to be 465 and 525, and I can see that's not in my restriction, my range. It's not right. And again, how do I know when to stop? Well, 2 ways to know. My numbers get too big, so I stop. Also, 2x tells me to go a total of 2 times. First time, second time. Let's try another one. Oh, and if you were to plug this back in, 105 times 2, and take sine of that, you would get negative 1/2. Let's try it, see if we can. I know you can't use these calculators, but we can still use it here to check. Okay, 105 times 2 is 210. I'm doing it right here. I'm plugging 105 in for x, and then I'm going to take sine of that number. If you can see that. Sine of 210 equals negative 0.5. I'm just going to check the last one, 345 times 2. 345 times 2 is 690. Take sine of that number, and again it's negative 1/2. So it truly does work. Okay, number 5. Secant 3x equals negative 2. All right. Secant is the reciprocal of cosine. So in your brain, you should be processing this. Cosine of 3x equals negative 1/2, because you take the reciprocal of this, not the reciprocal of the 3, the reciprocal of the answer here, negative 1/2. And then we use substitution. Theta equals 3x. Cosine of what angle equals negative 1/2. I'm hoping your brain is telling you 60 degrees. Cosine of 60 degrees is 1/2. 60 degrees is not one of our answers because it's negative, and cosine is negative in 2 and 3. So what is 60 degrees in those two quadrants? 120 and 240. This is our first time around. 3x tells me to go a total of 3 times. This is the first. There's the second. There's the third. First, second, third. And what I'm going to do is add 360 to both of these to get this set, and then 360 to these two to get that set. You can go ahead and hit pause and add 360 to see what you get. Hit play, and we'll go from there. All right. 120, 240, 480, 600, 840, 960. And then remembering that theta was really 3x. So on the last one, I divided everything by 2 because of the 2 there. This one, I'm going to divide everything by 3. So again, you can hit pause, calculate these numbers, hit play, and see if we end up in the same place. All right, this is my set of answers. Once I divided all of those by 3, I got 40, 80, 160, 200, 280, and 320. So yes, we're going to try one more and see how we do. Cosine of 4x equals 1 over root 2. Cosine of 4x. This is telling me I'm going to go to a total of 4 times around. There's really nothing special to do here. We can just think of our angle. Cosine of what angle is 1 over root 2? 45 degrees. Cosine of theta equals 1 over root 2. We're letting theta equal 4x. Is 45 degrees one of our answers? Yes, because it's positive, which means we're in quadrant 1. Cosine is positive in quadrant 1 and quadrant 4, so it's 45 degrees and 315 degrees. That's the first time. Here's our second set, third set, and fourth set. And I'm going to put pause here really quick. You can see all of our answers came out to be between 0 and 360. That should happen every single time. Okay, first set, second set, third set, fourth set. You're going to add 360 to these two to get the second set, 360 to those two to get the third set, and then 360 to each one of these to get the fourth set. Hit pause and do it on your own. All right, so this is what I get: 45 plus 360, 405 plus 360, 765 plus 360, and then I do the same thing with the 315. Now these numbers here you can see are way too big, but I haven't divided yet because this is 4x, not 3x. It's 4x, which means I'm going to divide everything by 4. So go ahead and hit pause, divide everything by 4, see what you come up with. Remembering decimals are our friends. It's okay to get decimals. Decimals come out on the test and it freaks kids out all the time, but decimals, there's nothing wrong with them. We can work with them. All right, 1, 2, 3, 4, 5, 6, 7, 8 answers came from these here. And as you can see, 11.25 is the smallest, 348.75 is the largest, and they're all in between 0 and 360. All right, that is it for this lesson.